In this video, we're going to be looking at integration, and that's A2 integration. Okay, before we start, there's a few derivatives you have to memorize, and I can't emphasize this anymore. You'll find integration terribly hard if you haven't memorized these. So please don't ask, are they going to be in the formula book? You just simply need to memorize them. So if you need to, just pause the videos and take a moment and memorize these. Okay, so I'm going to start with some very simple integration. So let's look at the first one, sec squared x. Think of something which differentiates to sec squared x. And if you remember your formulas correctly, you should have said tan x. And of course, don't forget the plus c, the constant of integration. Okay, so going to the right, we have cos x. Now, this is an easy one. What differentiates to cos x? And you should have said sin x. Okay, the next one is 1 over x. Now, this one, some students are tempted to turn it into x to the power minus 1 and do the AS integration, and it wouldn't work because it ends up making you divide by 0, which doesn't work. When you see 1 over x, you need to know the integration is ln x. Also note, when you integrate and you get ln as an answer, you need to put the straight lines rather than the curved brackets, the modulus signs. Okay, so next we have sec x tan x. And it's sec x which differentiates to sec x tan x. So on the next one, there is a slight tricky element. Think of something which differentiates to cosec squared x. There's nothing which differentiates perfectly to cosec squared x in the derivatives I gave you earlier. So we know cot x differentiates to minus cosec squared x, except here we don't have minus cosec squared x. So it's not going to be simply just cot x, it's going to be minus cot x. So we put minus cot x because cot x differentiates to minus cosec squared x. And here we don't have minus cosec squared x, we have just cosec squared x. Okay, moving on to the next one. Now we've got 3ex here. Now if it was just ex, we know ex differentiates to ex. So the only thing which makes it complicated is the 3. What I'd like you to remember is constants which are multiplying don't affect the differentiation or the integration at all. They don't really play a part. So since we've got a 3 in the question here, we can just simply put 3 in the answer and sort of leave it in the back of our mind, because it doesn't have any operations in the actual integration itself. So since we put it in the answer now, we can just sort of ignore it and just think about ex. What's the integration of ex? And you should have said ex. Another thing some people do is actually take the 3 outside the integral sign. So they'll have 3 integral sign ex. And here you can see it actually does not affect the integration. You're just going to times the 3 back onto the answer. So whenever you have constants multiplying on, I'd like you to think about that, and it makes it easy for the difficult questions coming up. Okay, so before we go into the integration by recognition, you need to be really good with the chain rule. And I know this is an integration video and I'll keep talking about differentiation, but it is really important that you know your chain rule very well. And when I say know it very well, what I mean is you should be able to do the chain rule without showing all the steps, going straight to the answer. We only show all the steps of the chain rule when the question says show using the chain rule. So let's just practice 2 differentiation questions and then we'll go back to integration. So the first one says tan 2x plus 3. And if we're going straight to the answer, you should have said, and we're going to use the chain rule, but we're going to go straight to the answer. Okay, so it's going to be sec squared 2x plus 3 because tan x differentiates to sec squared x. But of course, we haven't simply got x here, we've got 2x plus 3. So it's going to be sec squared 2x plus 3. But remember, you also times it by the differentiation of 2x plus 3. And the differentiation of 2x plus 3 is 2. On the right here, I've shown the general rule I've used to do this. Okay, let's look at the next one. We've got y equals sec x squared plus 3. And we know the differentiation of sec x is sec x tan x. Okay, there's one little thing missing. We also need to times it by the differentiation of x squared plus 3, which is 2x. And we're done. Now we can go back to integration. Okay, so let's start with A. So in the first one, we've got cos 5x minus 2. Now, let's think of something which differentiates to cos 5x minus 2. And hopefully you said sine. But of course, it's not sine x, it's going to be sine 5x minus 2. Okay, now there's something missing still. And we're going to find out the missing bit by trying to differentiate this, the answer we've given so far. If you differentiate the answer we've given so far, you should go back to the question. So what's the differentiation of sine 5x minus 2? It is going to be cos 5x minus 2, but there will be extra 5 in front of it because of the chain rule. So it's not going exactly back to the question. When you differentiate sine 5x minus 2, you get an extra 5 at the front. So we're going to adjust it by putting 1 over 5 at the front of our answer. And that will get rid of that 5, which will come to the front when you differentiate. Now, if you differentiate this, it goes back to the question exactly. So we're good on this one. Okay, let's go to B then. Now, I'll give you a moment to think about it. So it's going to be something to do with cot. So far, this is my suggested answer. Now, we're going to differentiate it. You don't need to write out the differentiation. If you practice the chain rule enough, you'll be able to do it in your head. And that's what I wanted you to get to before we get on to this stage of the video. Okay, so if you differentiate this, you get minus 3 cosec squared 3x minus 2. So you're getting an extra minus, which is not there. And you're getting an extra 3, which is also not there in the question. So it's not differentiating perfectly back to the question because of that extra minus 3. But we can adjust that. We can adjust that by putting a minus on and putting a third on to get rid of the 3. Now if you differentiate it, it goes perfectly back to the question. So we're good on this question too. Okay, looking at the next one. So we've got 7 at the front. So if you like, you can take the 7 outside the integral sign, if that helps. Or just put it in the answer and sort of ignore it, because we know it does not take part in the integration steps. Okay, so what differentiates to sine? Now, if you said cos, you're very close, because cos differentiates to minus sine. So what you want to say is minus cos. Minus cos will differentiate to sine. So we definitely need a minus in front of the answer. Now I left a space because I know there's going to be another number coming into play. Okay, now ignoring the 7, if you differentiate this, you get an extra 8 at the front using the chain rule, and we don't want that 8. So how are we going to get rid of that? We're going to put a 1 over 8. The issue of the negative we've sorted out and balanced it off by putting a negative on, so we don't need to worry about that. There, now it'll work out perfect. Let's just tidy this up a little bit. Okay, so let's try D now. Pause the video if you want to have a go. So here we've got sec tan, and we should know that sec x differentiates to something like this. The answer is going to be sec 2x plus 3. Now if you differentiate this, you get something very close to the actual question, except you get an extra 2 at the front. But that's really easy to get rid of. We're going to put 1 over 2 at the front. And we're good with that one too. Okay, so let's look at slightly trickier ones. So in these types, we always suggest an answer which has 1 higher power. Okay, now go ahead and differentiate this and see what happens. If you've forgotten the differentiation of this, I'm just going to show you the rule here. Okay, so when you differentiate it, you should realize you get extra 9 at the front and extra 2 at the front, which gives you extra 18 at the front. So we can get rid of that 18 by putting 1 over 18. And now it should differentiate back perfectly to the question. Okay, so I've shown you here the rule which you need to know to help answer this question. Now for these types, you're checking, is the top a multiple of the differentiation of the bottom? Now the differentiation of the bottom is 3x squared. Now, although you don't have perfectly 3x squared here, at least it's a multiple of it. So it's still fine. You can still follow this rule. So we're just going to suggest the answer is ln of the bottom, and that's what you do for these types. Now, if you differentiate this, you get 3x squared at the top. Of course, we don't have that 3 there, so we can simply adjust it by putting a third, and we're done. Okay, here's the rule you need to know to answer this question. And the key is to notice that the differentiation of the power on the e is at the front, but it doesn't need to be perfectly at the front, just a multiple of it. For example, the differentiation of the power x squared is 2x, but we've got 4x here. But that's fine, 4x is a multiple of 2x, and so it can be fixed by just timesing on a simple constant. Okay, so what you could do is ignore the 4, and we'll just put it in the question, and we're just going to put it at the back of our minds. So for these types, you just suggest the answer is e to the same power. Now I've left a space because I know a constant is going to go in here. Okay, so let's differentiate e to the x squared, and that gives us a 2x at the front. Of course, we're ignoring the 4, so that 2 is something extra, and we get rid of it simply by putting 1 over 2. And there we have it. I hope you found that video useful. Support us by liking, subscribing, and share this with your friends. And if you still got some more questions on anything, drop a post on our forum at examqa.com where you'll find your questions answered.